frugal engineering is also something I would say similar. So we say that low cost, low resource, and quality should be the same as a conventional product or better than it. Now you have to achieve all of this simultaneously. So that's what makes it challenging. So they are using this technology to make particle physics cost effective. So that is one extreme example of going frugal or advanced frugal, right? Which is high quality at a low cost. And you will see many also in like what you mentioned about Chandrayaan and Mangalyaan. These are all high quality science, advanced frugal innovations or AFIs in any sector in engineering. So you take any sector, the goal is low resource, low cost, and very good quality. So this in turn defines the different pillars of engineering. So you take manufacturing, you take materials, everything has to hew to these three tenets.
I was talking to another musician on this podcast, and he was talking about how he teaches creativity while imposing constraints. So we're talking constraints here, but does one sort of need to be more creative to be frugal engineer?
I think creativity is kind of an innate quality. Like some have it a lot and some are kind of okay. But yes, if as in any engineering discipline, if you're more creative and innovative, it pays a lot in frugal.
To become a good frugal engineer is to first become a problem solver. That you need to develop this mentality of taking on problems and going in the direction of finding solutions.
In India, we always hear this thing that people like to crack exams and whatnot. Okay, and you need to have a good understanding of concepts to do that. But many times the people who do things practically, maybe these guys are not successful there. But I would say that overall learning concepts is what should be the goal. It's extremely important because the way this thing started, there was a thing like, it's frugal. So, people had this view that what is the science in it? But a lot of them can read a book and also some of the publications, that is from our group. And these are all hardcore engineering problems. And we do frugal engineering, that is going advanced frugal for engineering. So very high level applications which will benefit a lot from going frugal. A lot of these things are resource and capital intensive and they are needed. So you need to frugalize to, kind of help society at large.
Namaskar and welcome to another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. As we like to think, this is your future simplified. This podcast is brought to you by the Office of Global Engagement at IIT Madras, IITM Global, which is an initiative of the Office of Global Engagement, stands for everything IITM and India that the world needs to be experiencing and benefiting from. Come learn more about their activities and their initiatives through a link in the description below here. India is a country which has done amazing things in engineering, but with a stripe that is our own, very frugally, very cost effectively. If you think of all of our engineered products that are manufactured in India and all of the engineering that we benefit from, it has come at a cost point that is somewhat unimaginable in the whole world. The best example of this was the Mangalyaan expedition that India undertook. The entire mission costed under 500 crores. Similarly, Chandrayaan is another testament to how one could achieve an end at a cost point that is somewhat unimaginable for anyone else. For that matter, this year's budget of ISRO would be probably 3 to 4% or 5% at best of what a NASA's budget of where a NASA's budget stands at. This thinking, this philosophy seems to pervade everything that is ours and engineering. This is going to be a way of doing engineering going forward. And increasingly, this has become formalized into a bit of a discipline into itself. Frugal engineering. And to talk about this whole discipline, the excitement underlying this discipline, the paradigm that defines this discipline, I have one of the world's foremost proponent and researcher, a good friend and a colleague, Professor Bala Krishna Rao, from our Department of Engineering Design here at IIT Madras. Welcome, Bala, to this conversation.
Yes. Thank you so much, Mahesh. Thank you for having me, and thank you for such a nice and generous introduction.
No, I think you've sort of gotten into this discipline at a stage when it was probably just getting defined. And today you've written the definitive textbook in this discipline. Tell us a little bit about what attracted you to engineering to start with.
Well, I think first, our family has been, from my father's side, a family of engineers. So engineers, some doctors, and also IAS and IFS people. But more so my father's side, father's father, he was the chief engineer under the King of Travancore in Trivandrum in those days. And he built waterworks for Kerala, for Trivandrum, which is still currently going strong. And it is gravity fed. It was done cost effectively, for which he got a medal from the King of Travancore at that point in time. And he was also called Vastu Vidya Kushala. So that was kind of an inspiring figure for all of us in the family. So a lot of us took to engineering, to go in his footsteps. And also for me, looking at others. And at that point in time also, I think a lot of us wanted to be into engineering or medicine.
So it looks like frugal engineering was part of your blood, your gene, for a very long time.
I had heard about this thing about my grandfather from my father, right? But I never took any, kind of interest in it as such initially when I went into graduate studies and all of that. But I do a bit of reading, and in the process came upon this thing about Jugaad. And which is just, there is no science or engineering in it, or what we call a grassroots frugal innovation. So you put things together and you hope that it works. So the quality is not, it's reasonable. So the diffusion in the marketplace might not be very good. But this was mainly for affordability. And that kind of struck me, and it looked like there were a lot of elements that, which could be used in engineering. And science and engineering could supplement this and make it stronger. So, and that is what I think I've been one of the early researchers and took the risk of getting into it, of starting this, or kind of getting, laying the foundation for this entire thing. And I thank IIT Madras for giving this opportunity, because we have a very conducive atmosphere here to take up high risk research. So basically, we took the Jugaad thing, and if you put science and engineering into it, you get what are known as advanced frugal innovations. So these are really sophisticated frugal innovations, which are low cost, low resource, but very good in quality. And to make that happen, you need this discipline of frugal engineering.
So that's a perfect segue into what we should be talking about next. Let's define what is frugal engineering formally. What are the paradigms underlying this discipline, and how is it fundamentally different from what you described earlier, Jugaad, which is a little bit more grassroots innovation?
Sure. So as for many things, many nice concepts in engineering, the definition for frugal engineering is very simple. But when you implement it, it becomes quite challenging. This is also like finite element modeling, right? It's more like a divide and conquer. You say that you divide the domain into elements and solve it piecewise, or, all that. Frugal engineering is also something I would say similar. So we say that low cost, low resource, and quality should be the same as a conventional product or better than that. Now you have to achieve all of this simultaneously. So that's what makes it challenging. And in the process, we are trying to create advanced frugal innovations, or AFIs, in any sector in engineering. So you take any sector, the goal is low resource, low cost, and very good quality. So this in turn defines the different pillars of engineering. So you take manufacturing, you take materials, everything has to hew to these three tenets. And so that is what frugal engineering is all about. So the normal engineering, but with added constraints of low resource, low cost, and very good quality. And you need a new set of tools to go with that. So in a nutshell, frugal engineering would be low resource, low cost, and attempting for the best quality possible. But I should add here that ideally you will have a very strong form of an advanced frugal innovation or a weak form. What if I satisfy only two tenets? I have affordability and maybe quality, but the resources used for not, the minimal. So that would be a weak form. So ideally, you can start with a weak form and then do research to get to the strong form, which is low resource, low cost, and as high a quality as possible. So all these are research endeavors now, because every project is a research project. Because you take this and try to work on it and see what you can get out of it. I'm reminded about Matt Damon, right, in The Martian, in which he tries to wring the most out of science to kind of survive there. So frugal is something like that, frugal engineering. You wring the most out of science to get this, because you're putting an artificial constraint on resources. So you might be living in, with a plethora of resources, but you try to put artificial constraints that I will use the minimal possible. So that becomes challenging, along with low cost and aiming for a high quality.
So, sometimes this seems like a bit of a sort of a paradigm that's not possible, that high quality can thrive with low cost. Can you give us some examples and maybe help our audience understand that they don't need to be at loggerheads with each other?
Thank you so much. Yeah, this is a very good question, and people many times they think this is quite counterintuitive. You want high quality but at low cost, and how would you do that? So research over the years has led to products which, from a frugal perspective, are all advanced frugal innovations. And one example that I give everywhere, this is an extreme example. This is a particle accelerator. So if you look at a Large Hadron Collider, this is like a 27-kilometer structure. And you typically accelerate these beams of charged particles. They are made to collide into one another. The elementary particles coming out, you study those, which is particle physics. It has ramifications for everything after that. And so the CERN in Switzerland has been also looking at alternative ways of doing that. And in 2014, they reported something called using plasma technology. So you have tabletop accelerators now. From 27 kilometers, it has gone to 30 centimeters. Using electrons, which are accelerated, and you do particle physics experiments with them. Not for all applications, but for selected ones. So you can clearly see that that's a drastic reduction in the resources. Quality is good. In fact, what this is doing now, the tabletop one, it is kind of a replacement for some of the things that the big one was doing, which is cost effective, and the quality is also very good. So CERN has now made this into a program called Awake. And I hope it is still there. You can Google that, Awake at CERN. So they are using this technology to make particle physics cost effective. So that is one extreme example of going frugal or advanced frugal, right? Which is high quality at a low cost. And you will see many also in, like what you mentioned about Chandrayaan and Mangalyaan. These are all, high quality science. I mean, people might say, your cost was so low, how did you do that? That's because you have a very good scientific workforce. And they have run the most out of science to make this possible. And coming to Mangalyaan, I read that, the entire thing, it costed less than setting up a single cricket team for IPL in that year. That's how good it was. Far less. That's how good it was. But they have not released the details, how this was kind of achieved, ISRO. So I would like to look at that. And ISRO's thing is it's a quintessential example of doing frugal engineering for making advanced frugal products in the space sector.
Is it only about cost, or are there other factors that are also involved in the paradigm to sort of be minimized?
Okay. You minimize cost and resources, but at the same time, you maximize your quality. So the approach that I have taken is I go with I try to minimize resources. I got some tools. One of them is called the factor of frugality, which is based on the deterministic safety factor. So we start with a low safety factor so that, you consume lesser materials. And then you look subsequently at every product development stage to save more and more material. The assumption is lesser materials, lesser cost. But you keep a keen focus on other activities too to keep the cost low, which is not directly mentioned. And at the same time, you keep your design very rigorous and accurate. You use the latest theoretical models, the best data possible. These have become cost effective. So your quality is going high. So lesser resources, quality is going high, and cost is also less. So yes, you're going for high quality at a low cost. Okay. So cost and resources are going low, but quality is going high. So that is the fundamental working principle for frugal engineering.
India has been a lab for frugal engineering for a very long time. We talked about ISRO, and I'm sure the Maruti 800, when it came out, was also was also thought of as balancing cost and quality in a manner that was hitherto unseen. Why is it that India is a good lab for this? I mean, you've also trotted the globe to sort of teach and research global engineering.
Right.
What makes India so different?
I think it is the dominant culture here where we respect nature. And we respect nature, and people talk about sustainability now, but in India there was always this respect for nature and make sure that the environment is taken care of. And we also had a very brilliant workforce which used to work with limited resources for a different reason, because we started out poor. We had, all the, the colonial rule and whatnot. And when India started out, it was, from a kind of a lower platform. But you did all this high quality science that was interesting at low cost. And so that has carried over the years. Although, we have now globalized and all that, it is, one of the top 4 richest economies in the world. But those principles are carrying forward, and also how people work. And I think this particular workforce that we have in India, they also share traits coming from, very, probably a bygone era. If you go to Delhi, you have this, the Delhi pillar. The Delhi pillar was an example of forge welding. And this was done at a time, at least what I've read, that, Europe and other places were trying to see how this can be done. And we had the technology. And to add to that, this was supposed to be a Dvajastambha in a Vishnu temple, Mahavishnu temple, to predict the summer solstice. So this is sophisticated at different levels. And it was done very effectively. And I think that the resourcefulness has always carried over with Indians. And now we started with lesser resources after independence. That resourcefulness and the work culture helped us. And with the result, many companies in India are now making what I would say advanced frugal products. Products that are very effective, but the cost is kind of mind-bogglingly low compared to what would be done in the West. Okay. But my issue currently with Indian engineering practice is to make sure that the quality doesn't suffer. Many of them, the quality takes a beating. So it's good, but I think many of them think that when it's affordable, you can skimp on the quality. But that's not what frugal engineering is about. For me, it's like, to get the same quality, but at a lower cost. That is what is challenging. And I think companies in India now have that workforce, entities everywhere in India have that kind of a thinking, workforce with that kind of a thinking to make it possible. I think it's only you need to teach them the philosophy.
Are there some disciplines of engineering that are more ready for frugal engineering than others? You take everything from software, computer science to mechanical, civil, chemical, material science. Are there some disciplines that are more ready, you think?
So obviously here, first of all, frugal engineering and the concept of advanced frugal innovation, so what we call the AFI movement, it can be applied to any sector. In fact, any product, even services. So what you see with Indigo and Ryanair, we call that advanced frugal service. You're trying to give quality service at low cost. Okay, it falls under the same concept, but slightly different principles. But again, you're minimizing resources there and also lowering the cost. But to answer your question, engineering, literally every sector is open to frugalizing with this discipline. And currently, yes, the mechanical and material sciences are directly related because they use material resources to make things happen. So I think that's the first, first set of sectors that can make the most of it. And especially automotive and aerospace can benefit a lot. Because all these people use very, sometimes exotic materials. And you look at the geopolitical crisis going on right now, the Iran war and all that, resources are finite, right? So something like this can help. How do I do this with finer, resources? And we have a very thriving manufacturing sector. And like I told you, frugal engineering is also about frugalizing the pillars of engineering. So there is a separate field called frugal manufacturing. And the strong form of this is, I will take a single process, single pass, low cost machine tool, zero waste and good quality. Okay, so this is a very stringent set of constraints. And you do that, you need new set of machine tools to make all of this happen. So yes, sectors like automotive, aerospace, materials, anything that uses all of that, supply chains catering to them and all of them, they can all go frugal and use this philosophy. And yes, the others like computers and all that, they do use hardware and whatnot. So the frugal engineering principles are again applicable there. How do you design this frugally? Last year, recently, I also came out with a new concept for, going stochastic in this because you have uncertainties. So we have developed a measure for frugal reliability. So we have a set of very formal and stringent tools which can help you do this in a very systematic way. It is not a scattershot approach. You can sit, nicely plan, meticulously, iterative, and get this whole thing done. So previously the frugal thing was all distributed around. So everything is now under one umbrella. So yes, you can apply it to different sectors in engineering, including AI, like frugal AI. Right? You can currently AI seems to be waste prone, but for obvious reasons. Because I think the world is also trying to set up the fundamental platform and the infrastructure for us. But at some point, I think they will see the light, and there's already talk of going frugal, frugal AI. And the same, again, I would say that frugal AI is an advanced frugal innovation in AI. The same concepts apply there.
So let's take one existing product and walk through the process of frugalization. Like, how do I take an existing process that is manufacturing a certain product and help us walk through the process by which you'll sort of frugalize the manufacturing and the design?
Okay. Currently, there are not many that are available that take you in all these separate steps together. So my group, there are now people working, and hopefully in a year or two, we are going to have some nice publications, automotive and glass making, where we are attacking all this manufacturing and all. I have some industry guys working on that. But one good example that I take people through in my classes and also when I give talks on this area, it concerns the South African Large Telescope. It's called the SALT. And I seriously hope ISRO comes out with a good thing on frugal engineering, can also help them to kind of view what they have done to come out something like this, and get an article published. Because they need to tell the world how they have done it. It's very interesting. And what SALT has done in South Africa is they needed a telescope to do spectroscopy with light. South Africa, I think they were cash-strapped to begin with. And they couldn't indulge into the kind of telescopy programs that Europe gets into. So to begin with, it was a cash-trap program. So they said, let's do something with it and see what we can. I would say this is one of the first documented instances of frugal engineering doing systematically. So they said we will look at only one. Since we are doing light spectroscopy, we can be at a relatively smaller altitude to begin with. That's about 1.7 kilometers above sea level, which I'm told that by telescopy standards, that's like quite low. Because usually you want to go as high as possible to avoid the light pollution. In fact, there is a telescope, I don't know how many know about it, in one of the base camps near Everest. So the height matters a lot. But here they went for like 1.7 to kind of lower the cost on that. And then they said, we need to look at only one patch of the sky. So you need only 1 degree of freedom to kind of rotate around the vertical. So all the mechanisms going into the other degrees of freedom are not there. So you're saving on resources there. That's the first frugal thing that they did. The second thing, all these telescopes need paraboloid mirrors, right, to focus the light. Paraboloid mirrors, trying to grind them, manufacture them is very expensive. If you go the normal route, like what US, Europe, or maybe even India does. So what these people did, it's very, very, very interesting. They broke down the entire telescope mirror into hexagonal elements. And these elements are later assembled together to make a mirror. Each hexagonal element is made in different parts of the world. So cost is reduced. There is more to it. If it is paraboloid, then every hexagonal element will have a different shape as a function of the curve.
Yeah.
Right? It's a paraboloid. So they said that can add to the cost. So they made it spheroidal. So now the hexagonal elements are the same, but now you have a problem with spherical aberration. So many, problems in physics. So they made a small software-based device to correct for spherical aberration. So with all of this, the equipment is working real well. This was an article that was published on it in Nature in 2013 on the SALT. So this was done frugally, and the whole thing cost about 1/3 of the cost of maybe Keck telescope in Europe, which is about 130 million at that point in time, euros. So that would be one example that I always mention, to walk through it. It had manufacturing, design, everything from scratch, how to go advanced frugal.
It almost seems like, is it that there were some small compromises on the full-scale functionality to get to this sort of cost point. Is that part of the approach, or how do you parse that?
Mahesh, as we know in engineering, when you kind of introduce a new product, you'll always have these teething problems. There are many variables. You try to foresee them, but you don't. And when you go frugal, one thing is, you're going with lesser materials and lesser cost. And many of the tools are not available to you, and especially more material or whatnot to take care of uncertainties. And yes, the salt had many uncertainties. In fact, it had some working problems when it began, operating. And interesting thing is, everything was corrected on site, and that became standard procedure, and they made it into a fully functioning product. So you make a frugal product. Yes, there are going to be some initial problems, but you learn along the way. But the more meticulously you do it, I think you will see lesser of those problems. So it can be done in a meticulous way. That's what I'm trying to say. And with something like a frugal engineering approach, you can go in a systematic manner. And so that, you can even simulate this on a computer to make sure everything works fine before you get into it. You look at some of the cars like Quid and others, right, from Renault. That's a frugal platform. And I believe my opinion that I think it came from the Tata Nano concept. Tatas were, I think, one of the first to get into it. A small car, a budget car. But engineering was quite sophisticated to make that. That's an advanced frugal product. They had some initial teething problems. That's bound to happen because you're trying it for the first time. And it was a very good concept. And I hope they continue to work on that and, make something good out of it. But Renault has kind of jumped on it. The Quid and others are supposed to be from that platform.
You had mentioned this earlier, the idea of Jugaad is, we're talking something that's fundamentally different from Jugaad. Help us differentiate these two sort of lines of thought.
So Jugaad is kind of marked by ingenuity. The people who do Jugaad, they are brilliant innovators, I think. The only thing lacking for, is the science or engineering. So they come from a strata of society, at least how this Jugaad began, right? The lower income segment, where many times you don't have access to many of the things we take for granted. So they make these things that just do this kind of some functionality reasonably and affordably. Affordability is very important here. So that I think the word Jugaad came from a cart, which is assembled from different parts, maybe a truck, a tractor and all that. And this can take you from point A to B. And there's another interesting slide that I show, somewhere in, I think, the north of India, there's this person making Jugaad cappuccino. Uses a pressure cooker to get the foam in the coffee, a 5 rupee cappuccino, okay? I'm sure he doesn't know the science or engineering behind it, okay? But he's making it affordable. So Jugaad was a makeshift thing with mainly affordability in mind. But Jugaad is actually a grassroots frugal innovation. But what we are looking at is advanced frugal. So you take the affordability, but combine it with low cost and very high quality, and you have to engineer it. So that is where you need cutting edge science and engineering to make it happen in a systematic way. So Jugaad is basically makeshift with no science or engineering, the bulk of it.
And there are frameworks that you can use to do this sort of Pareto optimization. Let's talk a little bit about the role of optimization in this whole frugal engineering paradigm. How do you bring in optimization? How do you write the objective function that you want to optimize?
So this is a very good question, Mahesh, and people keep asking me, what is so different about frugal? We have always talked about agile, and there was lean manufacturing, all these different philosophies of doing design and engineering. I would say frugal is one umbrella under which all of these fall down. I'll answer this question in two parts. By calling it frugal, it also gives it, there is a connotation that you have to be scarce in using whatever you are, getting good quality in a good way. Okay, the others don't give that. Lean is fine, but frugal is something that it really brings that out. And currently in this era of you have global warming and the demographics, population inching, numbers are going higher, finite resources. You need something like engineering which is tweaked to do this, and frugal does that very well. So you can say it's a grand optimization problem. So objective function might be like if you take something like a jaw crusher, which one of my students has analyzed, a traditional jaw crusher has very bulky components. So you take any component, one goal is to make sure that the weight is less, so you consume lesser materials. But at the same time, you have to make sure that the manufacturing that goes into it is also not wasteful, low cost, high quality, along with the design, and cost is kept low at all levels. So it's an optimization at a very grand level. So your objective function, which is kind of very fuzzy to define here, it is a function of your quality, your cost, and your resource. And there are many constraints. Constraints which are not forcing. Only when you start working, you realize that there's a cost element involved here for this particular functionality. Is it possible to do this at lower cost? but I don't want to, compromise my quality. So yeah, it is a grand optimization problem, kind of fuzzy, with an objective function that is a function of many parameters and several constraints.
I was talking to a musician on this podcast, and he was talking about how he teaches creativity by imposing constraints. So we're talking constraints here.
Right.
Does one sort of need to be more creative to be a frugal engineer?
I think creativity is kind of an innate quality. Like some have it a lot and some are kind of okay. But yes, if as in any engineering discipline, if you're more creative and innovative, it pays a lot in frugal. So I would say those people who are doing Jugaad, if these guys are given some support with science and engineering, or they are educated to make that, take those kinds of decisions, they can do a very good job. So creativity is very important. And it's very interesting, Mahesh, that you take an ordinary problem, just try it out and try to frugalize it. You will then see the innovation kicking in, because you have to do things in a different way now. There are constraints that you never thought of. So yes, the creativity plays a big role now, and it becomes a very cutting edge research problem. So you're looking for new avenues, and you get more creative in trying to see what you can do with it. And there is, I'm sure you have read this. I think a major problem now with Western science is they are claiming that there have not been many radical discoveries in the last 50 years. Like science is dwindling. We're getting a lot of these very incremental, gains, but nothing very radical. But one way to tackle that is just to go advanced frugal. You take any problem, you put these constraints. You have to get something new now to do that. And you might get something like, this frugalized plasma accelerator. A totally new technology which CERN was not ready for. So yes, there is a burst of creativity, and this field can help you do it in a very systematic way. And if you're innately creative, all the more good. It helps you a lot more.
That's a very nice takeaway point. I think creativity with this systematic training in frugal engineering equips you very differently. Let's talk to students, right? And you say this is a paradigm that can be learned by all disciplines of engineering. It can help practically many different disciplines of engineering. If I'm say a mechanical engineer or a civil engineer or a chemical engineer, what can I do while I'm in college to sort of equip myself to sort of become a frugal engineer or a frugal innovator?
I think one suggestion or advice, at least my opinion, humble opinion, would be to learn your concepts very well. And for this, take as many courses in the fundamental sciences while you're doing an undergrad program. Or even for that matter, master's or PhD, whenever you start this, the learning process might start late sometimes, we never know. But it's very important that you need to have a decent or a good grasp of subjects like thermodynamics, heat transfer, fluid mechanics, vibrations, mechanics, plasticity, elasticity. All these things play a big role here, because you're trying to use science under dire constraints, very stringent constraints. So you need to have a good grasp of these things to make it happen. So one word of advice for students would be to really learn well. Take as many courses as possible. You never know when this might come in handy. Maybe not frugal engineering, but this never goes, to waste. And develop a reasonably okay reading habit. Read on a daily basis probably. Stuff which can make you better over time.
And are there courses now available that students can take to sort of to be trained in this paradigm of frugal engineering?
Well, I took one with NPTEL with the Sustainability Center here, but that was a very brief one, spanning 2 classes. We are now trying to do this as a regular course with the Institute of Machine Design and Tribology at Leibniz University, Hanover, where I'm a adjunct prof. So we are offering a full level graduate course there. So I would like to repeat that probably here, and there's also been talk of doing that here. But the first set of courses were given here in IIT Madras. They are on NPTEL. People can take a look. 2 lectures. The one in Leibniz will just be a little, an elaboration of that with some more examples and all that, which I hope to do that here, offer also in IIT Madras and elsewhere.
It to me looks like one of the underlying mental traits students need to acquire to become a good frugal engineer is to first become a problem solver. That you need to develop this mentality of taking on problems and going in the direction of finding solutions. what has been your sort of training, your view of how to become a problem solver?
I think, Mahesh, that is again a very good question. And in India, we always hear this thing that people like to crack exams and whatnot. Okay. And you need to have a good understanding of concepts to do that. But many times the people who do things practically, probably, maybe these guys are not successful there. But I would say that overall learning concepts is what should be the goal. And you take interest in the subject. Anytime you take interest in something that you're doing, it is no more painful, right? Marks are important, but I think your main goal would be to learn the concepts very well and make sure you understand what that thing means. And so when you solve a problem, that concept is you'll go at a conceptual level, how this thing works, and that opens new doors, right? Actually, how to tackle that problem fundamentally. So if students can just take interest in what you're doing, I mean, you're coming into engineering, naturally there is a liking for engineering. And if you continue that interest, there is always this pressure of, scoring marks and whatnot. But I think you should try to cultivate that even under pressure, to like what you're doing. And in that process, you try to learn the concepts. And what better place than IIT Madras, because, you have some of the best professors here teaching all these fundamental courses. And I always tell my students to take advantage of that. You ask questions and learn as much as you can. There's one place you can, get all of that. So that actually strengthens your concepts and makes you a better problem solver. And maybe also a better exam taker. So understanding concepts is very important, fundamental.
Sure. I think liking what you're doing and doing what you like are both equally important in some way. That you get into a profession that you really like.
Yeah.
And that in itself is a joy.
Yeah, I
And
concur with you.
how important are internships in this whole process?
I think internships are very important because for undergraduate students, that's a first stepping stone, I believe, into the real world, right? When you work in a research lab, in a government national lab or a private place, you learn all these concepts, but then you see how they are done practically. Practically, the constraints are very different. You need to know the concepts, but there are so many things happening. How do you tackle that? And number one, you see how people do that and you learn from it. And number two, with all these concepts, you try to solve a problem for that entity. So internships are very important. To know how good you know your fundamentals, so you can solve something for them, and hopefully it is useful. And also to see the real world working of, all things that go into science and engineering. So internships are very important, and they should be taken up seriously and done seriously.
You, in your profession, have worked with a lot of companies, in trying to help them go frugal. What have you seen as the practice on the private companies side? Clearly, it helps their bottom line.
Right.
But how open are they to embrace this whole field right now?
They are, in fact, get several calls from companies, and Indian companies are very interested, and I see a lot of interest from Europe, because they are now realizing how to maintain that quality with lesser resources. And that is what even I see a common theme in India with our private sector people here. End of the day, I think what they like is there are lesser resources here. So it's a lesser cost for them, which will affect their bottom line. And hopefully this is passed as a lower cost to the consumer. But I'm not an expert in that. I think that you need policies and all that. It's a different area completely, how it, how this is given to the consumer. But companies definitely like it, because if you can get, there is a formal discipline to help you achieve what you're doing at lower cost without compromising the quality. What is there not to like about it? But one issue is currently, I've noticed that sometimes, some of these people try to skimp on the quality, because, hey, you say affordability, so I can't give the same quality. But that is the trap we should not fall into. Affordability is important, but you can't compromise quality. And quality includes safety and all of that, right? So there are many things where safety is built for a reason. And some things directly involving human safety is of utmost importance. So you have to do frugalization in a very careful and methodical way. So when there is affordability and lower cost, lower resources, companies have to keep in mind that you should not compromise on the quality. And this frugal engineering will help you with that, to go in a systematic manner, if done correctly.
Last question on that. I think it almost seems like if I want to frugalize a product, do I need to understand different streams of engineering? Or if I'm good at the fundamentals of mechanical engineering, can I fit into this puzzle?
That's a good question, Mahesh. And I think ideally you would want to know all the different streams, well, to make use of it. But that's not going to happen. It's kind of just too much out there in terms of knowledge. But if you're good even in mechanical, that's a good place to start with. And those concepts will help you where to look at. And this is going to be an interdisciplinary team effort. You can hire other experts under that umbrella to go frugal. So each does, advanced frugalizers whatever he is given to based on his expertise, he or she. And then you assemble all of this to make the final product. And so currently it's a interdisciplinary teamwork required, with research teams either in companies or even in government labs or in places like IIT Madras. So students currently now look at one part in which they are a domain expert and try to frugalize that, right? And at a higher level, you need many such experts to work together to make it frugal.
You mentioned advanced frugal many times in this conversation till now versus frugal engineering. What is the differentiation there?
Okay, the differentiation is that all started with Jugaad or what we call grassroots frugal. Okay, let me make this. I think this classification is very important. Frugal innovations were like you make a part that is affordable, a service or a device or product that is affordable. That's how it was defined. Affordability was of main importance, and this came mainly from Jugaad, which were called the grassroots frugal innovations, mainly affordability. But then with affordability, you sometimes skimp on quality, and the other main thing about Jugaad or grassroots frugal or the original frugal movement, there was no science or engineering in it. So they saw all these people making things, like putting things together. And here the thing works. You never thought that this could do what it is supposed to, but it works. This is frugal. It is kind of affordable and it is simple. But there was no formal science or engineering into it. So now you're defining advanced frugal, which takes that and makes it better. So you're going for affordability and lesser resources, but at very high quality. And you can't do that without science and engineering. And in fact, like I told you before, it's every, such project is a research project. So this is an advanced frugal movement, a new movement. This is not, I would say that grassroots frugal were frugal innovation 1.0. Advanced frugal is frugal innovation 2.0. Okay. It's better to call it advanced because by calling it frugal, you have your particle accelerator and something like a Jugaad. You can't put them on the same, level. There is a difference in them, in the sophistication of technology and how it was achieved. But having said that, there are innovators in both the sides who might be similarly innovative or enterprising. But you need very good science and engineering to make advanced frugal possible. And so there are many countries now jumping onto this advanced frugal movement. Of course, Germany is one. We also have interested parties in South Africa now who are into it. And I also know somebody in the UK, United Kingdom, who is the new entrant to this movement. So hopefully I have cleared that up.
Very nice. I think we are at a moment in India when we want to build globally admired products, not just globally affordable products.
Right.
I think frugal innovation and advanced frugal innovation is the right paradigm for us to push in that direction, don't you think?
I'm completely with you on that. I think this Make in India movement is very important. You have to find products globally where you'd say, yeah, that is coming from India. And it's happening now. You have companies like Tatas and Mahindras who are getting into aerospace and they're making good cars. And, we are making slowly making a splash on the global front. And the good thing about frugal engineering is people acknowledge that the origins are in India. Mainly India and to some extent China. So this is seen like more an Indian movement.
Very nice.
And the frugal engineering and advanced frugal innovations were done here at IIT Madras. Okay, it took about 15 years. So this is a completely Indian initiative. I would say it's a Make in India philosophy for good engineering. Okay, where we do engineering differently, but the quality is not sacrificed. So there is a very strong Indian angle to it. And products coming out, I think, hopefully, we'll be very proud of them. They will have the good quality and everything else that we want in an AFI.
I think, like you said earlier on, we have a philosophy of respecting nature that is inherent in our culture.
Right.
We are used to old newspapers getting recycled into, into covers for our
Right.
use in our vegetable shops.
Right.
That's something that didn't happen today. It has been the way of our life for 30, 40 years now. I think coming back to the college view of frugal education, I mean, this is not something that is yet being taught in colleges.
Right.
What can we do to have this be more pervasively taught in colleges?
And I think at least from a IIT Madras perspective, we should start offering courses in frugal engineering and frugal manufacturing. Okay, and I'm ready for that. I have the quantum of work to kind of get that going and involve the labs and centers into it. And once we do that, I think IIT Madras is a leader in kind of all these new educational platforms and whatnot, and we can set a kind of a standard for others to follow, where this can be offered as a formal course, and as along with all the things that you take in an undergrad, you can offer this at an undergrad or a grad level, and accordingly teach people about it. We are currently, in my group, there are students now graduating with formally in frugal engineering, what they have done. And I think the material is ready to make it into a proper course, and IIT Madras can lead in it so that others can follow.
Very nice. I think just as we argue that every engineer graduating out there should have graduated with some understanding of AI.
Right.
Because that's how pervasive that tool has become.
Yes.
I would like to argue that frugal engineering should also be, should be in their toolkit when they graduate. I think we should get to that point soon.
Yeah. I'm with you. In fact, as we talked about, right, frugal engineering is getting wedded to AI with the frugal AI thing. So one thing, yes, you cannot be, you have to be savvy in AI now. Some amount of AI. You might not be coding and all that, but at least how to use these tools like Claude and others. They're doing a lot of things which some time back was not thinkable. And how can even the using of that be done in a frugal manner, right? I use lesser of these tools, but very effectively. So the cost is curtailed, and you get a good output. So yes, I think frugal and AI, or frugal AI, or even separately doing frugal engineering and AI will be sets of tools that will help you a lot.
My takeaway from this conversation has been that this is a discipline that is extremely grounded in hard science and engineering. And that's where we derive the optimization and the value for the customer. I think that's a very important takeaway for all our students, I think.
Very much, Mahesh. And that's extremely important, because the way this thing started, there was a thing like, it's frugal. So, people had this view that what is the science in it? But a lot of them can read the book, and also some of the publications, at least from our group. And these are all hardcore engineering problems. And we do frugal engineering, that is going advanced frugal for engineering. So very high level applications which will benefit a lot from going frugal. A lot of these things are resource and capital intensive, and they are needed. So you need to frugalize to, kind of help society at large.
Thank you, Bala. This has been a wonderful conversation. Thank you for coming on and talking about this very exciting new discipline that I'm not sure how many have already heard of. I think it's important that more people hear of frugal innovation, frugal engineering, and maybe even frugal AI as we go forward. Thank you again.
Thank you so much, Mahesh. Thank you for having me here. And really, it was very nice meeting, on this platform and talking to you. And wish you the very best. And I see a lot of nice people coming on this podcast. Keep up the good work. Thank you so much.
Thank you. Thank you very much, Bala. Can India solve problems for 1 billion people? Not by spending more, but by doing engineering smarter. The answer is yes, frugal engineering.
And if I can add one thing,
Yes.
if you don't mind, this is a tagline that I give everywhere. Please buy the book and help a frugal professor.
Surely. I think it's the world's first textbook. And as
It is.
Bala says, it's India's own paradigm of
Yes,
doing
sir.
engineering.
Yeah, it is.
Thank
It
you
is.
very much for that. I think it's an important part of our learning journey.
Thank you so much.
Until we meet again, be well, do good, and keep in touch. Goodbye.